The objective of this lesson is to multiply a whole number by a fraction less than 1 using physical models and drawings of set models. In previous lessons, students have multiplied a whole number by a unit fraction with models. Students should be encouraged to use this as a strategy for finding products using non-unit fractions as a multiplier. When multiplying fractions less than 1, the product is a smaller set of objects, a shorter line, or a smaller area compared to the starting amount. Students should be encouraged to identify the whole being referenced and to label their answers. We will start this lesson with the following problem. Sally had 6 cakes to frost. She had 2/3 of them done by break time. How many cakes did she have frosted? This problem is asking, what is 2/3 of 6? The multiplication expression 2/3 times 6 can be written to represent this problem. This problem can be modeled by using 6 rectangles to represent each cake Sally must frost. 1/3 of 6 can be found by dividing the 6 cakes into 3 equal groups. 2 cakes are equal to 1/3 of the total number of cakes. 2/3 of the cakes would be equal to 2 groups of 2 cakes or 4 cakes. The answer is less than the original 6 cakes because only part of the cakes have been frosted. It is important for students to understand the difference between these two multiplication expressions, 4 cakes times 6 and 2/3 cakes times 6. In the first expression, 4 times 6 cakes are being iterated 4 times, or there are 4 groups of 6 cakes, which equals 24. In the second expression, 2/3 times 6 cakes, only part of the 6 cakes are being used, or 4 cakes. Another way to represent this problem is dividing 6 by 3 because we want to find out what 1/3 is, and then multiplied by 2 because we need to find 2/3. Let's look at another example. Brian has 3/4 of a dozen eggs in his carton. How many eggs does Brian have? It is important for students to understand that we are looking for the number of eggs, not the number of dozens of eggs. This problem is asking, what is 3/4 of 12? The multiplication expression 3/4 times 12 can be written to represent this problem. This problem can be modeled by drawing a 2 by 6 grid. Each square in the grid represents an egg. 1/4 of 12 can be found by dividing 12 into 4 equal parts. 12 divided by 4 equals 3. 3 eggs are equal to 1/4 of the dozen eggs. 3/4 of the eggs would be equal to 3 groups of 3 eggs, or 3 eggs times 3 groups equals 9 eggs. This problem focused on situations where the whole number was divisible by a denominator of the fraction without leaving a remainder. The following problem has a whole number that will not divide evenly by the denominator. Shelley had 7 cakes to frost. She had 2/3 of the cakes frosted by her break. How many cakes is that? This problem is asking, what is 2/3 of 7? 2/3 times 7 can be written to represent the problem. This problem can be represented by showing 7 rectangles, with each rectangle representing a cake. In our previous model, 6 cakes divided by 3 groups is equal to 2 cakes in each group. This problem adds on an additional cake. This additional cake must be divided into thirds, so that 1/3 of the additional cake can be placed in each group. Each group would contain 2 and 1/3 cakes. 2/3 of the cakes would be equal to 2 groups of the cakes plus 1/3 of the additional cake, or 2 groups times 2 1/3 cakes equals 4 2/3 cakes. Shelley would have frosted 4 whole cakes and 2/3 of another cake by her break. Another way to model this problem would be to divide each cake into thirds and shade 2/3 of each cake. By counting the 1/3 pieces, students can see that 2/3 of 7 cakes is 14/3, or 4 2/3 cakes. Here is another problem in which the whole number will not divide evenly by the denominator. Dave was saving money to buy boots. The boots cost $45. He has saved 6/10 of the money needed. How much money has Dave saved? This problem is asking, what is 6/10 of 45? This problem can be modeled by showing a rectangle divided into 10 sections. Each section represents 1/10 of the money needed to buy the boots. Each section of the rectangle is equal to $4.50. Since Dave has 6/10 of the money saved, 6 boxes out of the 10 would represent the money he has saved. The total saved can be found by multiplying $4.50 times 6. This equals $27. The expression 45 divided by 10 times 6 could be used to represent this situation. The objective for this lesson was to multiply a whole number by a fraction less than 1 using physical models and drawings. We met this objective by modeling the problems, by writing equations, and by using drawings of set models.